Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A finance team just pulled the wrong purchase order number from 12,000 invoices. Their AI pipeline looked at each scanned document, but disconnected services meant no secure context was shared. One bad API call later, supplier payments are frozen, and the CFO's calling an emergency board meeting. The fix is a unified AI platform that handles models, data, and security together. Azure AI Foundry. Here's your 60-second review of Part 1. We created Azure accounts, spun up a Foundry hub and project, and deployed a model behind an endpoint. If you haven't built that yet, here's your quick win. Open the portal, search AI Foundry, create a hub, then create a project. That's the environment we'll be deploying agents into today, so have it ready before the next scene. Before Foundry, an IT team juggling AI services deals with scattered authentication. Every service wants its own API key. Then costs hit blind. You can't tell who ran what, so you get a surprise bill. And data flows through multiple tools with no content safety. Foundry unifies all of this. One identity, one monitoring pane, one content safety layer. Think of Foundry as the nucleus. Around it, 6 pillars. The model catalog gives you over 1,600 models to compare. Prompt flow is your visual orchestration canvas for chaining calls and custom logic. AI agents handle multi-step reasoning. AI search retrieves your enterprise data using hybrid search. Security enforces content safety and access control. Monitoring traces every token. That's your map for the rest of this video. Your app calls the Foundry hub. The hub routes the request to the selected model, say GPT-4o, or to an AI agent. If the agent needs factual context, it queries AI search indexes, which pull from your SharePoint or Blob storage. And the whole path is wrapped by Azure Monitor, Key Vault, and Content Safety. That's the architecture in one breath. Open the portal. The left nav is your command center. Start at Hub. That's your shared spine for networking, security, and billing. Projects are the workspaces where you actually build. Model Catalog is where you browse and compare those 1,600 models. Prompt Flow is the visual editor for chaining LLM calls. Deployments shows live inference endpoints and their status. And monitoring gives you token consumption and latency traces. Memorize these. You'll live in this nav. When you create a hub, Foundry typically sets up supporting resources. An AI search instance for retrieval, a key vault for secrets, a storage account, application insights for monitoring, and a container registry for custom compute. Azure OpenAI isn't part of that initial setup. You'll add model deployments inside your projects. But these are the services you'll be looking at when you need to debug. One hub, 2 teams. The HR team has a project with their own PDFs and a fine-tuned Llama model for benefits Q&A. The finance team's project holds invoice data and a GPT-4o deployment for document classification. Each project runs in its own isolated environment, its own data connections, model deployments, and settings. That means HR can't accidentally see finance's data. That's governance built in. Hub versus project. One hub per region handles the backbone, network isolation, shared search, billing. Inside that hub, you create multiple projects. Each project is a sandbox. You deploy your models, connect your data, run evaluations. If you're about to deploy a model and you're not sure you're in a project, check the top bar. It'll say Hub if you're at the wrong level. Create one hub, then many projects. Although Azure AI Foundry provides a unified development experience, it's built on top of several Azure services working together behind the scenes. Azure OpenAI powers language reasoning through deployed foundation models. Azure AI Search indexes enterprise documents and retrieves relevant information for retrieval augmented generation. Azure Storage securely stores datasets, uploaded documents, and other application assets. Azure Key Vault protects secrets, connection strings, and encryption keys. Application Insights and Azure Monitor collect operational telemetry, performance metrics, and diagnostic logs. If your solution uses managed compute for open-weight models, Azure Container Registry stores the container images needed for deployment. You won't always create each of these services manually, and not every project uses every component. But understanding their individual roles makes troubleshooting and designing enterprise AI solutions much easier. Nobody starts by training a 175 billion parameter model from scratch, unless they hate money and free time. Foundry's model catalog lists over 1,600 foundation models already trained on internet-scale data: GPT-4o, Llama, Mistral, Claude. You grab one of these, fine-tune it on a few hundred domain examples if you need to, then ground it with real enterprise knowledge through RAG and Azure AI Search. That three-step chain, pre-trained engine, your flavor, your facts, is how you go from generic to production-ready without a PhD in machine learning. The model catalog contains a growing collection of foundation models from Microsoft, OpenAI, Meta, Mistral, DeepSeek, and many other providers. Selecting the right model isn't about choosing the newest or largest option. It's about matching the model to your business requirements. Compare models based on response quality, reasoning capability, latency, pricing, context window size, multimodal support, and licensing requirements. A smaller model may outperform a larger one for routine business automation while costing significantly less. Before deploying any model, evaluate it using your own data rather than relying solely on public benchmarks. The best model is the one that consistently solves your organization's problems within your performance and budget goals. GPT isn't one model, it's a family, and picking the wrong one can 10 times your bill. Hit pause and think. If you're using GPT-4o for a simple intent classifier, you're burning cash. Use Mini. The flagship GPT-4o handles heavy reasoning, perfect for an agent that has to look up a ticket, check Active Directory, and compose a polite reply. GPT-4o Mini is the economy option, fast and fine for straightforward tasks. Need to read a screenshot? Vision's your pick. And O1 Preview is the overthinker. Use it only when the answer isn't obvious and you're willing to pay for deeper analysis. Open weight doesn't mean free. You still pay for the Azure compute that runs them, but they can cut costs dramatically on high-volume pipelines. Here's the trap. Beginners assume open models are slow, but on managed compute, they can rival GPT-4o Mini for throughput at a fraction of the price. DeepSeek v3, Llama 3, and Mistral are all available in Foundry's catalog, deployable via managed compute with a few clicks and a GPU SKU. For batch RAG or overnight analysis, an open model often drops the bill significantly. The key is to evaluate them on your own data, because the model that wins on a generic benchmark isn't always the one that wins on your IT docs. Model choice is a skill. This is the 60-second decision that separates a junior from a senior AI engineer. Client-facing chat? You need accuracy, context, and safety, even if it's a touch slower. That's GPT-4o territory. Internal automation, like scanning 1,000 tickets for the right KB article? Throughput wins. A small open model running on managed compute can deliver sub-200 millisecond responses and cost a fraction of GPT-4o. The Foundry benchmarks help you spot that difference before you wire the first credit card to the meter. Browsing the catalog helps you evaluate models, but applications never communicate with the catalog itself. They communicate with deployments. A deployment creates a managed inference endpoint that applications call whenever they need AI reasoning. Standard deployments automatically scale to meet changing workloads and are well-suited for development and variable demand. Provisioned throughput reserves, dedicated processing capacity for organizations requiring predictable latency and consistent performance under heavy workloads. Because deployments abstract the underlying model, you can update versions, test alternatives, or adjust capacity without redesigning the application architecture. Separating model selection from deployment is one of the key architectural principles behind enterprise AI platforms. Prompt flow isn't just stringing together 3 prompts. You drag nodes onto a canvas. A user query hits GPT-4o for a first draft. A Python validation step checks that the response is valid. JSON, before passing it downstream, then a second LLM call, summarizes only the useful parts. Most beginners build a flat chain without validation, and then spend days debugging hallucinated output. The validation node is your insurance. Between any 2 nodes, you can drop a conditional branch, load data from Azure AI Search, or call an HTTP API. You're building a logic pipeline, not just a text chain, and Foundry's visual debugger lets you trace every decision after the fact. I see tons of new users skip the playground and go straight to production code, then wonder why their agent is a hallucination factory. Don't do that. Always test prompts here first. I set a system message that tells the model it's an IT help desk assistant and to keep answers short. I type, "I can't connect to the VPN," and hit enter. The model comes back with checklist-style troubleshooting. Perfect. But the reply feels a little too creative, so I drag the temperature slider from 0.7 down to 0.3. Now it sticks to proven steps with no hallucinated suggestions. That's the exact behavior you want for a real help desk bot. Multi-turn conversations are where AI agents earn their paycheck, and the chat playground lets you design those flows before you write a single line of orchestration code. Multi-turn testing is how you catch the agent going off the rails before users do. Skip this, and your chatbot might demand a user's password by lunchtime. I simulate a real IT ticket. The user complains about a locked file. The assistant asks for the file ID. The user provides it, and the assistant verifies access and suggests the unlock command. Once I'm happy with the sequence, I click export and save the entire conversation. System prompt, temperature setting, top P, straight into a JSON config file that I can drop into production. Prototype here, then ship with confidence. Most beginners skip this screen and regret it. The playground gives you 5 dials that control exactly how wild or disciplined your model gets. Temperature is the big one. Most models default to around 0.7. Great for creative writing, but for an IT help desk that must follow precise KB articles, lower it to 0.2 or even 0.1 to stay factual. Max tokens is the silent budget killer. Set it to 150 for a short reply, and if you accidentally let it cut off a JSON object mid-field, your automation breaks. Top P gives you an alternative randomness control, and the penalty numbers stop the bot from becoming a broken record. Learn these 5, and you'll spend less time fighting hallucinations. Before you ship an agent, you need to know if your prompts actually work. Foundry's evaluation tool lets you upload a test dataset, say 50 real help desk questions with the correct knowledge base article as the answer. It runs each question against your model configuration and scores accuracy. And here's the lesson. On a narrow IT support test, the cheapest model sometimes beats the most expensive one. This is why you evaluate before you deploy, not after. Plug in your own dataset, run the built-in metrics, and pick the model that wins on your real data, not a leaderboard. A mid-sized company rolled out an internal chatbot to handle routine IT questions. No evaluations, no content filters. 2 weeks later, an employee typed a prompt injection. The bot responded with a string of profanity visible to the whole department. They yanked the bot offline for 4 days, scrubbed logs, and sent a company-wide apology. This is the failing pattern, shipping without evaluations, the exact controls we just covered. Don't be that company. The Azure AI Agent Service bakes in guardrails, content safety, and monitoring from the start so you never end up in that board meeting. Next, we're building agents the safe, governed way. Most IT teams jump straight to agents for every chatbot, but you only need the agent service when the task requires multi-step reasoning or external actions. Otherwise, you're paying for orchestration you don't use. An agent is not just a chatbot that replies. It's a reasoning loop that can retrieve context from data sources like Azure AI Search, call APIs to take actions in your environment, maintain context across turns, and operate within safety guardrails. Foundry's agent service packages all that into one managed runtime. You define the tools, connect the data, set the rules, and the agent executes a plan. Not just one response, but a sequence of actions. This architecture is what separates a prototype from something you'd actually trust in production. Most beginners get stuck here. They try to build a custom connector for ServiceNow from scratch. Don't. The agent service already has built-in actions for common integrations. You just configure them. You get 5 powerful ways to give your agent real-world abilities. Function calls with a single Python snippet. Knowledge grounding that pulls from AI search, memory for coherent conversations, built-in actions to external systems, and custom tools for anything else. You assemble these when you configure the agent, and the service orchestrates them at runtime. No spaghetti code. You don't need to fine-tune a model to teach it your environment. Upload 200 past resolved ticket PDFs into an Azure AI search index. Attach that index to the agent as a knowledge tool, and it can answer new tickets using retrieval augmented generation. That means the agent pulls the relevant chunks, injects them into the prompt, and answers with your actual data, not a hallucination. SharePoint pages, SQL-based documentation, Confluence wikis, all fair game. If your team already wrote it down, it can become the agent's brain in minutes. Enterprise data has weird product codes, serial numbers, and exact strings. Vector search alone misses those. Azure AI Search solves that with hybrid search. It runs a keyword match on the raw text and a semantic vector search simultaneously. Then, a final semantic ranker reorders the results for relevance. The top 3 chunks get injected into the agent's prompt, grounding the answer in your real data. That's how you avoid hallucination and make the agent trustworthy. You configure the index once and attach it to the agent as a knowledge tool. No custom plumbing. Enabling content safety is critical, and you can fine-tune its strictness for each category, hate speech, violence, self-harm, to fit your audience. For an internal tool, you'd want rigorous filtering. For a public chatbot, a balanced threshold reduces false alarms. Foundry applies safety checks before the model receives input and after it generates a response. Skip this, and you're one profane reply away from a call with legal. Security in Foundry builds on Azure's enterprise identity. Managed identity lets your app authenticate without storing credentials. Assign roles. Contributor for those who deploy. Reader for team members who need visibility. Use private endpoints to keep model traffic within your virtual network, and bring your own encryption keys to satisfy compliance. This is the security conversation an auditor expects to see. Deploying an AI application is only the beginning. Enterprise AI systems require continuous monitoring to ensure they remain reliable, secure, and cost-effective. Azure Monitor provides infrastructure visibility, while Application Insights traces every request, dependency, response time, and failure throughout the application. AI-specific metrics such as token consumption, response latency, groundedness, retrieval quality, citation coverage, and safety events help teams evaluate not only system availability, but also the quality of generated responses. By combining operational telemetry with AI evaluation metrics, organizations can detect regressions, optimize prompts, control costs, and continuously improve user experiences long after the initial deployment. Costs for an AI agent on Foundry depend entirely on which models you choose and how many tokens you burn. The biggest expense usually comes from the large generative model. A simple strategy: first, route every request to a cheap open model for classification. If it's a routine task, handle it with a direct API call or a small model. Reserve the expensive model for complex reasoning. That alone can cut your bill significantly. Before you go live, open the Azure pricing calculator, plug in your estimated token volume, and set budget alerts. Don't let your first bill be the wake-up call. Your agent doesn't exist in a vacuum. It needs to reach into your existing stack, and sometimes take action. Here are 6 real integration paths you'll wire into production agents. Logic apps. An agent fires a workflow that automates an IT operation, like calling Microsoft Graph to update a user attribute, if your environment supports it. Azure Functions. A tiny Python function probes an on-prem SQL server through a hybrid connection, pulling legacy data without a migration. Service Now. The agent creates an incident instantly when someone says, "Printer down," and the incident ID drops right into the chat. Azure SQL Database gives your agent direct, parameterized access to inventory or order data. Microsoft Teams turns agent replies into adaptive cards posted to a channel, so the whole support team sees the answer. And Blob Storage is where you park 500 past ticket PDFs for Azure AI Search to index for RAG. When you're ready to wire these connectors into code, check the latest SDK docs for the current import name. It could be Azure AI Projects or Azure AI Generative, depending on when you're watching. Pick the connectors your team already uses. You bring your agent to life with a single package import, Azure AI Projects. That replaces the old multi-SDK headache. Authenticate with default Azure credential. It automatically picks up the managed identity of your app service, so you never hard-code a key. Then create a client, point it at your project, and call the chat completions endpoint with the exact temperature dial you already tested in the playground. That is the whole pipeline. If you're working in CRs, the pattern is the same. New project client with the same credential, then the equivalent async completion method. For REST, it's a post to your deployment endpoint with a JSON body. But the SDK cuts the boilerplate out, so you stay focused on what the agent says, not how you called it. Building an AI application in Foundry is not a straight line. It is a loop. Design, develop, evaluate, deploy, improve. Design means writing your system prompt and picking tools and knowledge sources. Develop is coding the agent logic with the SDK. Evaluate is where you run the 50-question accuracy test we covered earlier. This is the step beginners skip and pay for later. Deploy the agent to production, then watch real usage. And improve loops right back to design. You tweak the prompt or swap models based on what you learn. The single most expensive mistake you can make is skipping evaluation. The loop is continuous, and Foundry gives you the dashboards to write it. Let's bring everything together. At the presentation layer, users interact through a web application, Microsoft Teams, or another business interface. Requests are forwarded to Azure AI Foundry, where the AI agent service orchestrates the conversation and determines whether additional knowledge or external tools are needed. The reasoning layer uses deployed foundation models through Azure OpenAI, while Azure AI Search retrieves relevant enterprise information using hybrid search across index documents stored in Azure Storage and other connected data sources. Supporting every interaction are Microsoft Entra ID for authentication, Azure Key Vault for secure secret management, Azure Monitor and Application Insights for observability, and Azure AI Content Safety for responsible AI controls. Each layer performs a specific responsibility, creating a modular architecture that is easier to secure, scale, monitor, and evolve as business requirements grow. This layered approach is why Azure AI Foundry is more than a collection of AI services. It is an enterprise platform for building, operating, and governing production AI applications. Every one of these mistakes happens in real production. The fixes take minutes. First, using GPT-4o for simple classification is like delivering pizza in a Ferrari. Swap in a smaller, cheaper model like Phi 3 or a lightweight Llama variant. Check current pricing, and your cost can drop significantly. Second, hard-coded API keys eventually get leaked. Use managed identity. Third, without content safety, you're one prompt injection away from a company-wide apology. Fourth, a max tokens limit set even a little too low can silently corrupt JSON, breaking downstream systems. Fifth, if you never test with a real dataset, you're guessing. Foundry's evaluation tools give you a number, not a feeling. And sixth, set a budget alert right after creating the hub. 6 easy fixes that put you ahead of most first-time builders. Quick checkpoint. When you build your own help desk agent, what temperature value will keep it from going off script? Before you go, here's a quick win. Open Azure AI Foundry, create a new prompt flow, and hook in a simple retrieval step using one of your own documents. That alone will teach you more about RAG in a few minutes than any video can. Next up, you are building your first real AI application in Azure AI Foundry. You'll create your own Foundry project, deploy GPT-4o Mini, build an IT help desk RAG agent that answers tickets by searching real PDFs you upload to Azure AI Search, and test it with live questions, all in a single guided session. Hit subscribe and the bell so you don't build it blind. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.